Okay, I'll get started. So what I'm going to talk about is generally just securing the IoT, since Timur basically said there's no security in IoT and embedded devices. There's a lot to do with it and a lot of reasons why. I'm going to get started talking about a lot of different things that go wrong and a lot of things that we can fix in embedded systems. So a little bit about me. I'm in the Los Angeles area. I'm a senior pen tester for Belkin, so my job is to secure the Internet of Things per se. I'm also another chapter leader. I do Cloud Security Alliance in HTCIA, which is with the private and public sector over here in the U.S., mostly like Secret Service, FBI. There's my Twitter handle there if you'd like to get a hold of me. So we're going to talk about just a little, go over the light basics of IoT, going into the protocols and the supply chain of making these devices, and how many devices are out there, and then what the real issues are for security. And I'm going to talk about the resolutions, things that we can deploy and fix and make the devices more secure. Here are the basics here. So, according to Gartner, the Internet of Things is just a network of physical objects that contain embedded technology to communicate and sense or interact with the internal states or the external environment. Like the cloud, you have an embedded device from your local network contacting the cloud and coming back into your local network to control your devices. You have things such as wearables, you have security cameras, you have smoke alarms, you have thermostats for all smart homes, but then you have the smart cars, which have internet enabled. I don't know if you've seen the commercials, if they're over there on your side of the world, but they're giving cars 6 months to a year free Wi-Fi, as well as other applications installed in their car. You also have wireless sensors and things for your body as well that have wireless control for electromagnetic pulses through your back. You have smart buildings, smart cities, just completely wired from usually Zigbee protocols, which we'll get into a bit, to communicate with other devices in the city as well. So let's get started with the hardware. Whatever it is, whether it's smart city, wearable, smart home, you'll start with some type of hardware device, typically in a smaller form factor. These are just easy, things you can buy off the shelf, like Arduinos and Raspberry Pis, Raspberry Pi 2s, and pan steps. But the thing to keep in mind is that these devices or these hardware platforms are really, really cheap. Like this pan step is like $18 US, while the Arduino and Raspberry Pi 2 are about $40 US, which is not a lot of money to start creating your own project. You can get creative with it by adding on operating systems and frameworks. There's OpenWRT AllJoyn that is making an attempt to create a standard for all IoT devices to communicate in one type of transport communication way. You have Riot OS and you have HomeKit, which is proprietary, that requires a secure element to store information on the iOS devices specifically. There's no plans to go to Android, so there's a little bit of issues there, but it has, it's more like a hub of, let's say, home automation. So where these devices also communicate, internally within the network, it has to call out to their platform, which will be the cloud, that has some sort of API that connects these devices for control. So you can control it through your mobile app, which is typically what it is, mobile app or some sort of control panel that has an application to where it calls out to the cloud, keeps a connection open, and calls back down whenever it would like to, basically traversing your local network. So you have platforms like everything that connects your business apps, your consumer, your products, things in the market, QR codes and things that will eventually be deployed. So you have just these platforms. You have everything. You have Microsoft Azure's platform as well, which all have different protocols. There's nothing that standardizes with protocols though. So you have Zigbee, Z-Wave, Lutron, Bluetooth, LE, which is low energy, MQTT, and you have things like REST and SOAP and GSM, which it's kind of a Wild West because everybody basically makes their own standard for whatever they see fit, and they're not really playing nice with other devices as far as with the I don't know, I would say layer 7 application layer of controlling these devices, which makes it hard for other people to integrate. They may have their own SDK, but it'll be not very scalable. So you have things like hubs that will kind of glue it all together. So you have the Wink Hub, Insteon, and SmartThings. For example, the Wink Hub has peripherals that can control Z-Wave devices, Lutron, Bluetooth LE, Wi-Fi, and Zigbee. A ton of options there that kind of controls everything from one app. But it's kind of a shame that it takes devices like a hub to control these all these other devices in the ecosystem. And Wink and Insteon and SmartThings are kind of for home automation right now, smart homes, but you'll see them later on as they get deployed into businesses. Maybe beefier hardware and bigger type of appliances, but just to keep kind of control of the different protocols. You have these things called hubs. So there's according to Gartner, 4.9 billion devices that will be connected in 2015. Now that's a lot of devices. To think that they all have different protocols, different hardware, different chipsets, different functionalities, different apps. They can be on iOS, they can be on Android, Kindle, whatever it may be. 4.9 billion devices is a lot. And to think, how can we keep those secure with so many different variables in play? So I want to get down to the details of a little bit of the details on how these hardware devices kind of get started with the board support packages, the BSPs, people like Marvell, Broadcom. You've probably seen these in your PCs or your Macs, your Linux. You see them mostly as Wi-Fi chip vendors, but they do more than just Wi-Fi. They're the people who create the drivers to connect to the SDKs that will talk to the motherboard. So that's the key thing to take away from this, is that they create the drivers that you can talk to. A lot of the times people say that, hey, I get a binary blob, but it's these guys who will distribute that binary blob for their drivers. Now you have devices that routers that may be open source that these companies might be able to open source their drivers for whatever the purpose is. Security folks generally want to be able to patch their own or customize their own kind of drivers. So you have ODMs that basically take the SDKs that the BSPs post or give to them, where they can design and basically create a minimal stack, a software stack with a basic user interface, a web server, or something like that that's usually rebranded to for a bigger company, another company, or smaller companies that distribute it out. And they provide their own SDKs as well, and APIs that communicate to their software stack that has been designed. There's many of these ODMs, typically like in China, and there's a lot of them. I mean, I'm on design calls over here at Belkin, where I'm basically vetting out these companies that have no idea how to secure their ODM stack and their API, or even scalability for the API. So I've seen a lot of them. I've talked to a lot of them. And we'll get into a little bit of the positions later of what ODMs consist of. So with building these devices, like I said, you have to have some sort of platform. So you have a cloud service provider, Amazon, Microsoft, Google's. And ODMs even have their own. So I couldn't create my own company if I want to, and some do. That not only create the software stack, but also create a Amazon account that also can host your app's infrastructure and what your hardware talks to. So I mean, and these kind of clouds pop up. I mean, they'll call it their own, but it's usually in the back end, either Google, Microsoft, or Amazon, typically from what I've seen. Then you have people like Belkin, who's an ODM, who actually offers warranty and support and licensing of the product, where we deploy it and we kind of put our name on the line. At the ODMs don't, they don't really have their skin in the game, as you can say. They're not worried about certain issues or scalability issues, because they're just creating these software stacks that they're just going to give to an OEM to build their own software stack. So, security in that, I'm not too sure if the developers even care. But here's the supply chain of IoT and some of these devices here. You have the BSP, the ODM, the CSP, which is the cloud provider, which can also be combined with the ODM, and then it goes off to the ODM, who then deploys it massively to the whole world. So in each of these, likely to outsource development to multiple other teams. You might have the BSP that has 3 dev teams, one for the kernel, one for service, whatever it is, one for the hardware architecture. Same thing for the ODM, one for the web server, the UX, the user experience, the user interface. And the cloud service provider, I mean, that's, they mostly have pretty good guys for security if they're using, the Amazons, the Google, and the Microsoft. And then OEM, I mean, I'm not too sure on how many other companies like Belkin have security teams, but it's not even just Belkin. I mean, you have other companies that also create these devices and deploy them throughout. So, and keep in mind that these hardware pieces, whether it's the chips, the peripherals, you have a Zigbee interface or a Z-Wave interface that also tacks on to the board, the main PCB board. They all come from different places, and these boards are all soldered together from different places. So when trying to keep that secure, I'm not sure it's too feasible. They're just trying to get it out the door, and they have hundreds, millions, thousands, billions, whatever it is, devices that they need to get out. So the primary roles of these typical like ODMs would be sales, project managers, or program managers and engineers. And their typical responsibilities, sales basically to get the business and outreach to companies that may be interested, calling back, people who are interested in creating their own business, entrepreneurship, creating relationships with big companies, because that's a lot to do with it as well when creating chips and different chipset vendors. And PMs are just worried about prioritizing objectives and seeing, what should get done before this project. And then it's usually project specific to an engineer team, like I was talking about with UI and UX. They have different focuses, and it's their concern is just to get the product out, like any other software development type of company, with engineers who write code, and either it may be big or maybe small or maybe outsourced to 3 different other contractors, but they all have different workflows, and they all may have different training or lack thereof. But who's looking at security? From the companies I've talked to and that I've researched, and I've tried to do some LinkedIn searches as well. There's so much to worry about with even just embedded security, going down to the BSP level. You have common attacks with the TCP layer and tool chains that get installed from the BCP or the ODM. Maybe the BCP only creates the drivers and the ODM creates their stack on top of it. It kind of varies in that end. You have UART, which is serial connections, and JTAG interfaces, which are also common. And less common would be like Flash and GSM, GPS, kernel type of vulnerabilities. So then you have these people who also have to worry about Android app security, or they should be worrying about as far as ODMs, OEMs, or just the whole supply chain. Typically, an Android app the ODM can create this as well, if the OEM doesn't require that they have to. Usually, for these IoT companies, they make it so easy to create this rapid development of these devices so they can get it out to market. So with Android, I mean, we have typical, web view security and, permissions with Android manifest and memory for buffer overflows, because on the device, it's still relevant, and creating sessions over SSL so you can have that confidentiality to where you're talking to the platform, the cloud, and coming back down to your local network. You have iPhone security as well. Depending on what iOS SDK, there might be some vulnerabilities. There might be, with HomeKit, maybe they might not know how to securely input something into their secure element, or they might duplicate it out to the log or something, just so they can have some debugging enabled. And data protection APIs, web application security. There's just so much that they have to worry about. But who's worrying about it? There's no one specific. We're leaving all the responsibility on the developers, who may not have any experience in that. So they're not experts, and that's why we kind of think of embedded devices and IoT as kind of like a fail, because how are we supposed to keep track and know who's responsible for all of this type of security with web app, mobile, and hardware and embedded? Let's start with some security downfalls. I found this really good article here that says that's kind of what I'm trying to explain, and kind of my point of the talk is, it says, because computers go through so many hands before they're delivered to you, there's a serious concern that anyone could backdoor the computer without your knowledge. Depending on which code it's kind of written in, it could be in something as, system language code, HDL, that you will never hear or see of a backdoor unless it's somehow communicating unencrypted or not during startup. You have things like, people have seen this with router vendors, with backdoors using user agents and secret codes that open up a telnet session. You have debugging scripts that give you information disclosure, and those are typically from the ODM. They're not typically from the OEM, because it's used and needed for manufacturing purposes that off the line meaning manufacturing, they use it to test. For whatever purpose, they need some of these debugging scripts, from what I've seen and what I've read. And then you also always see and know that UART pins are always exposed. Usually it's either UART or JTAG, but UART pins can be, silkscreened, epoxied, or something like that to make it a little bit more difficult, or kind of sway the researcher to kind of look otherwise. But even when UART pins are exposed, they're typically not authenticated with a complex password. Usually it's pretty simple. There are plenty of DEF CON talks about it. They crack them within, an hour or so. But it's kind of scary because you see private keys on devices, where vendors and developers, they kind of think, hey, no one's going to look in the binary. It's in the binary. It's safe. It's not like mobile devices where you have a sandbox and no other devices can enter that sandbox. These devices are in people's homes. They're going to crack them open. You don't know exactly what they're going to look into. As far as they're concerned, as their device, they have full control over what's inside of that device. And they have every right to. I would, and I do. So here's some ideas that we can secure, the embedded world. You can restrict shell completely from any external type of interface. Like I was talking about with epoxy and silk screens, you can have very long passwords. If you're going to leave the UART connection exposed, the pins exposed, you can update kernel packages, update kernel and the packages, because you have other libraries involved as well, whether it's UPnP, SMB, any DHCP packages, and you also have to keep these updated with secure updates, whether it's pinning, GPG signing, some sort of cryptographic signing, as well as the use of, getting down to embedded with secure C functions. When you have leaving your buffer, or you use gets or string copy or anything like that, there's a whole list that we can go through. But these devices are like mobile devices where buffer overflows and things like that and command injections are very, very real. And they're mostly because these kernels are old, and the developers who are C developers don't know what is illegal as far as banned functions are concerned with C. So we all have to verify and test before these devices are out in production. So I have a couple funny little infographics here that I found with regards to C functions. Let's just look at that for a little bit. All right. So now you have, because of the impact that these devices may have with, 4.9 billion just within a year, people like FTC or the EU Commission are starting to take notice, like, hey, this is going to be a pretty big deal, and it's not going to go anywhere. It's not just a movement, it's not just a word. It's kind of the same way mobile computing and cloud computing. Everybody gets stuck in the semantics, but now we all know mobile's mobile and cloud's cloud. It's not such a big deal anymore. It's reality. So FTC and the EU Commission are starting to publish documents like implement security by design and privacy by design. So here's here's a quote from FTC. They've been posting, say, like 4 articles a year and workshops as well. One of them stating, implement security by design rather than grafting security on as an afterthought. Build it into your products or services at the outset of your planning process, which is key, because if you can't just bolt on security. Security is not a product; it is a process. So I mean, they're now starting to categorize IoT devices, whether they categorize routers as IoT devices. They categorize, because now, just like how we have here at Linksys, we have our routers controlled via mobile apps now. We can set port forwarding now for when we're away, kick people off our network, whatever it is. You have cameras, and you have smart homes for categorization of IoT devices. So it's kind of going to everywhere with wearables and things like that. And since these companies, IoT companies, they don't really have like a PCI or any type of like bank regulations or anything like that. This is the biggest protection to consumers as far as smart home is concerned. There's a lot of standards organizations that are thinking and worrying about the enterprise deployment of these IoT devices. One of which I'm a part of, which would be with Cloud Security Alliance. It's called IoT for Early Adopters, which we are trying to create a standard for deployment, secure deployment, and device management and such. So if anybody is interested, please feel free to message me. But with all these regulatory posts or articles or press releases, from the FTC or EU Commission, there's something missing that I don't see. They're talking about implanting security by design and privacy with software development, but again, these developers, PM, salespeople are not security professionals. So what's missing is the supply chain of these devices that I kind of went through earlier. How can we make this more secure? How can we make the supply chain more secure? I would say liability to the ODMs that, hey, there's not going to be any backdoors. There's not going to be any debugging scripts enabled by the time we deploy, and have some legal repercussions, with these partners that you're making deals with, because the OEM is taking all of the PR hit, the public relations hit, everything that's posted online. You have post after post. You have bigger PR firms. You have bigger news entities that are posting things about security now. So it's pretty important that these type of service agreements should be made with repercussions to that agreement as well. Community projects as well. So to get the awareness going with IoT, get involved with the project and kind of help out, get started early on. That way we're not, as security professionals or developers or PMs, working backwards to build in security. So as the FTC was saying, get involved in the planning process, which is into the software development lifecycle. Having just a security thought or a mind, a person who's there to give that input, is key. Here at Belkin, this is what we're doing. We have planning sessions with our project management and our program managers on how we should deploy this camera or whatever it is. We also, I think we need a common certification similar to Wi-Fi and Zigbee, to have that kind of sticker on there that says, hey, these conform to these standards, and then or collaborate with these groups. I'm involved with meeting groups, working groups with Wi-Fi Alliance and Zigbee Alliance, but these type of conversations aren't really ongoing for common certification where we can add security into it. So is it realistic given the supply chain? Not too sure. just because of the so many hands and so many teams involved. You know, you would think just for a simple app and a simple device, you'd have like maybe a handful of teams involved for engineering team, but in reality, there's way more. It's broken down into functionality, so you have a setup team or a functionality team, whatever it is, or a certain new feature, a hot fix, or anything like that. But ways to help, you know, aside from getting community projects, is being on the offensive side and breaking these devices with Build It Securely and Bug Crowd. Build It Securely has, you know, a number of researchers readily available to test these devices before they go out to production. So this gives you a way to secure, you know, the consumers or whoever is deploying this device, whether it's for the enterprise or consumers. So get involved with Build It Securely. Mark's a great guy, and so is Zach. Bugcrowd also has, you know, they have Wink right now. We're also we might be getting involved with Bugcrowd and give, you know, the hardware devices for security researchers to test. You know, we're all in this to keep everyone more secure. We don't, you know, there's nothing to hide as far as our organization is concerned. Like I said, we have things like OWASP, where I have, you know, some defense strategies that developers, you know, can reference. You know, for embedded, for IoT, they have the IoT top 10. I'm just creating the embedded security project within the week. So feel free, if you need any of these resources, I'll be happy to help anybody out. That'll be it. Thank you.